You're working with the large dataset stored in distributed file systems such as HDFS or Cloud Object Store like S3. The dataset is continuously growing and you need to optimize the storage and query performance. How would you design the data partitioning strategy for this dataset? What factors would you consider, and how would this strategy improve the both storage efficiency and query performance? So before me going and answering this question, I would like to explain what you're trying to do here. So in the databases, the same as in data warehouses as well, what you do is you're running the full, you basically like running MapReduce, or you're running the full table scan. And the thing what you want to do, you want to reduce amount of the data you need to scan to be able to answer business question or to answer the analytical question, right? So for those reasons, like for example, why you would hear things like, oh, never write, like select star from a table, always specify the columns you want. The reason why you want to do that is because you want to reduce the amount of columns you're actually pulling out. Or, someone would be saying like, well, always specify the partition predicate, so you would be pulling the data lower. So first of all, let me go and try to explain what is the partition predicates, or like in general, like the data partitioning, right? So this is our things which we don't need anymore, so we can delete that. So now imagine you have a massive database, right? Or you have sort of like a S3 storage, doesn't really matter. Right, so this is our database or S3. Now, when you're putting, like semi-structured data, or just in general, like the data in the database, what you're actually doing, you actually have a file, and this file has a different blocks. It's let's say it this way: you have a file, right? Like you have a file, and then you might have another file, you might have another file, and another file, and another file, and this is where your data is laid out. So now, when you run the query, and your JSON and your data just in one place, the query engine basically needs to take all of these files, needs to scan all of these files and find the question what they're asking for, like right, need to find, like the rows it is interested in. And if your data is not anyhow partitioned, it will just need to pull the data, all of that, right? So what is the data partitioning? So the data partitioning is basically introducing some sort of like, like some sort of like a categorization. So one of the way could be country, right? And let's say country equal US, right? And then this is, now let's take all the files out. This is our database. So this is our country partition. Now from all of these files, we only take, files which would have country equal US in it, right? And we'll just add it in here, and then we add another file, and then we add another file, right? So now I can take, like, and create another partition where the country is Canada. And now again, I would need to put all the files where, and maybe for Canada, we only have one file, and then, like so on. And this would be, like some another country, like say Lithuania, right? So now we have another, and then again, it might be, like a small file where the country is Lithuania. Now, when you run your query and you say select star, or like select count rows from table, from this table, it would actually still analyze all the files. But the moment you say select star where the country is US, it actually says like, oh, you actually want only these 3 files from, let's put this back, you want all in these 3 files because they matches the country US. Or you could say like, like where country is Lithuania, LT, and then you will only get this one file. So now the query engine needs only to open this one file. It basically needs files because we told him that only in this partition, only in this file, there is data about the Lithuania or Canada or US, right? So that's sort of like the idea. And you can go partitioning, deeper. You can add like multiple levels, but what you need to understand at some point, like maybe it's doesn't make sense to have a country, like as Lithuania, because they might only have like a tiny file about the data with that, and it's just like too small. And what you would rather want to do you want to say, like other, and then you say like, okay, you're going in there, but then you need to know when you can use the US, when you can use country, Canada, and when you can use other. So in this case, what is more rational to do is to introduce things like, like regions, for example, Europe, US, and this depends where you're running the business. So this is one part. Now, another way, and which is sort of like also very useful thing, is introducing a dynamic, not really dynamic, introducing a hashing partition. So instead of running, like country, you need, but this is actually, you need to understand your data very well and need to know if that can work for your data. So for example, if you are a Facebook, which works with a lot of users' data, right? So what you want to do, and like what you do, you always like take the user data and you join with another data, and always there is a user ID which in there, right? Like you cannot really filter out by the user ID because you end up having like billions of the partitions and it will be like very small files. So what you want to do, you want to take some sort of like, like where the user hash is some sort of like hash function where you would put like a user ID and you put saying that I want like, like 512 buckets of that. And what it would do, it would then basically return the answer, like from 0 to 511, right? So like 512 elements, and they would put the file where user hash is actually equal to, let's say to 0. And this one's, let's say here would be, like the user hash is 0. And here the user hash would be 511. And then this one would have the user, hash 511. So what it helps us to do now is now you have all the user data distributed into 512 buckets, and whenever you're dealing with like a single user or something, you just need to read one 512 from all data set which you have about these users or that sort of like informations. And then you can add like the other strategies as well around that. But again, like you need to find a balance between amount of the files you create and sort of like like amount of the partitions you have, because you cannot really go too far with this, because if you go too much you will be in the situation where your query engine basically needs to pull a bunch of small files, and having small files is not really that effective, right? So you would want to have as files around like, it depends on the many factors. It depends on how big is your like the query engine which you're using, how much memory you have in there, and other things. So I mean, don't go with 512, start with 32, start with 6 or something, right? Like just sort of like take a number, divide it by another number, and see that it would be like reasonable, it would fit better in, like it would fit ideally into your memory, and just go with that. Yeah, and that's sort of like what is partitioning, and then partitioning strategies. So yes, so you're working with the large data sets stored in a distributed file system, and the data continues to growing. You need to optimize the storage and query performance, how you design the data partitioning strategy for this data set. So because the data is constantly growing, it means that you're adding data as you go. So most likely we'll introduce some sort of like a time-based partitioning. Then depending from the situation, I would introduce some sort of like hashing partitioning. Actually, let's answer this question, right? So right here, because data is constantly growing, I assume that there is some sort of add-on or upstream every date. So I will add a time-based partition, like a date, I would also consider adding a hashing partition for user ID or session ID or some other property field which is used in many tables. Yeah, I think that's should be it in a nutshell, right? It's spot on. Let's break down time-based partitioning. And this is the advantage, hash-based partitioning. So again, partition by commonly queried fields, distributed data evenly across the partitions. That's what you want to do. Combining timing and bash. Of course, now when you have two, you basically would need to run queries. Factors of consider partitioning strategy, query patterns. Of course, like that's the thing, right? You need to look into what query patterns you have so you would know what data you're joining with, and maybe you would identify that, oh, I actually use this column on everything and I would want to join that. The data volume, the skewness, and yes, like, and all of those things. Yeah, completely agree. And I think we nailed it.